Welcome back to our discussions and thank you for always joining us. This is K.c.s.e 1991 paper 2 question number 11, and the question we have reads: use differentiation to find the x-coordinate of the maximum point of the curve. The first thing we are going to do is to find the dy over dx, which simply means the gradient function of the given curve. For us to find dy over dx, we are going to differentiate each term independently. X cubed becomes 3x squared. Remember, when differentiating, we bring down the power, then we go and less 1 from the power. We move to 2x squared. We are going to bring down 2 so that we have positive 4x. If we less 1 from power 2, we are simply going to have 4x power 1, which is the same as x. Then minus, you differentiate minus 4x, you get minus 4. We do not differentiate minus 8 since we are differentiating y in respect to change in x. Even if we were to differentiate minus 8, this is the same as minus 8 raised to the power of 0. We are going to bring down 0, then we go and less 1. 0 times anything will be 0, and therefore we do not touch minus 8. We know at maximum point, the dy over dx will usually give us a 0, and therefore in this case we are going to take the given function, that is the dy over dx, that is 3x squared plus 4x minus 4, and equate this to 0. This is a quadratic equation that we are going to solve quadratically using product sum factor method. To get the product, we take the first term here times the last one. So positive 3 times minus 4 will give us negative 12. And the sum is usually the linear term or simply the term at the center. And this one is going to give us 4. So we need two factors whose product will be negative 12 and their sum positive 4. The two will be negative 2 and positive 6. After doing that, we bring down our function. The quadratic term, which is 3x squared, remains the same. Then the linear term, which is positive 4x, is replaced by the two factors, that is minus 2, but of course x plus 6x minus c, which is our constant, and this one will be equated to 0. Once we have done that, now we can factorize the two parts in pairs. 3x squared minus 2x, x is common into, we have 3x minus 2. This is the same bracket we are going to get here, 3x minus 2. Then the common factor between 6x and minus 4 will be positive 2. Once we have done that, we can now bring together the two terms that are outside the brackets, that is x plus 2. And of course, we pick one of the brackets, that is 3x minus 2, and equate this to 0. Once we have done that, we can say x plus 2 will give us a 0. If you take positive 2 to the other side, the value of x will be negative 2, or 3x minus 2 will give us a 0. We move negative 2 to the other side, 3x is going to be equal to positive 2, then divide by 3 on both sides. The value of x becomes 2/3. Once we have gotten the two values of x, we can find the point that is going to give us a maximum. And if you go through this question, you realize that the value of x at the maximum point is going to be negative 2. Therefore, x will be equal to negative 2. We have already gone through stationary points. You know how to determine the maximum stationary point, minimum stationary point, and a point of inflection. If you want to do that, You can find the y coordinate when the value of x is -2, and the y coordinate when x is 2/3, and of course determine the nature of the 2 points. You are going to realize that -2 is going to give us the maximum stationary point, and that is what has made us to conclude that the x-coordinate of the maximum point of the curve is -2. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. For any revision materials, support, or online classes, feel free to contact us through 0701 686 283. Thank you.